Hey, Algebra 2, we're going to move on today. We are working on lesson 10.3, and we are doing composition of functions and inverses. You did this in Algebra 1, so I do not think you will have any problem with it, but we will be going over it. I'm kind of giving you an extra lesson this week just to prepare for next week. Our essential question is, can you find the composite of two given functions and find the inverse? Well, for sure, after this lesson, you will be able to do that. So let's look at example 1. Example 1 says, if f of x equals 3x minus 5, and g of x equals the square root of x. Remember, this f and this g are the names of what function we'll use. So the first thing we have to know is order of operations tells us to work from the inside out. So we are going to start with the g function, and instead of putting in the number x, we're going to put in the number 4. So if I find g of 4, instead of putting in the number x, I'm going to put in the number 4. So I know the answer to g of 4 is the square root of 4, which is 2. So what I'm going to do is replace this and find f of 2. Well, again, that says, hey, go to the equation that's named f and put in the number 2 instead of the number x. 3 times 2 minus 5. 6 minus 5 is equal to 1. So the answer in this case of f of g of 4 is 1. That is our answer right there. Sorry, my equal sign is kind of mixing in. So we have to remember that the f and the g are never going to be in our equation or our answer. That's just what the equation is called. This one is called the f equation, and this one is called the g equation. Now I'm going to erase all this so we can go ahead and see what to use for the next examples, because the examples kind of all use the same g of x and f of x. So let's look at g of f of 4. So like last time, I'm going to start with the inside. I'm just going to find f of 4. F of 4 is, instead of putting in x, I'm putting in the number 4. And 12 minus 5 is 7. So I'm going to replace the f of 4 and put 7 in here. And I'm going to find g of 7. We're going to go to the g equation. Instead of putting in x, we're going to put in 7. So the answer to g of f of 4 is the square root of 7. You do not have to find a decimal for that. Now, a lot of times they're just going to give us an x. So we're using the same exact information that I know, because this is all in the same problem. So g of x, hey, that's already given. Look at g of x is the square root of x. So now I'm going to take the f, oops, let me get a darker color. I'm going to take the f equation, and instead of putting in x, I'm going to put in the square root of x, because that's what g of x is equal to. So this is just going to be 3 times the square root of x minus 5. And the last one, they're telling us to put f of x inside of the g of x. So we're taking this 3x minus 5, and we're putting it underneath the root, 3x minus 5. And really, that's all we can do. All right, the last thing we're going to do is talk about inverses. So what we just did is called composition of functions. And now we're going to go ahead, and it's asking us to show that f of x and g of x are inverses. Well, there's a little note right here that says, hey, to find the inverse, plug in f of g of x. And I'm going to show you one other thing, because what you'll see mostly on an SAT or con work is a different way to do inverses. So let's plug in the g of x, which is 3x plus 3 for this x right here, and you'll see what happens. So f of g of x, I'm going to take the f equation, and instead of putting in x, I'm going to put in 3x plus 3. And I have 1/3, and now on the opposite side, I need this -1. And yes, we do have to distribute. So I get x plus 1 minus 1. So we know that this is equal to just x. That means that this is an inverse. But I'm going to show you one other thing. Let's just go ahead and look at this g of x. If I was to find just the inverse, let's say all I needed to know was the inverse. First of all, they would state that as finding the inverse of g of x. What I tell my students to do is I say, hey, let's call this g of x y. And what we're going to do is switch the x and the y. So notice I'm going to take x equals 3y plus 3. So number 1, switch x and y. And then number 2 is just solve for y. So if I was to solve for this y right here, the first thing I would do is subtract 3. X equals, sorry, I just messed that up. X minus 3 equals 3y. And when I divide everything through by 3, I get 1/3 x minus 1 equals y. So if I look back, notice this y in purple is the exact same thing as this right here. So if you didn't have the inverses like this question gives and you had to actually find the inverse, you would just go ahead and do these steps right here, switch the x and y, and solve for y. Great job, Algebra 2.